Thank you for watching our video today. This one is going to be about setting up the LI-5800A analyzer, alkalinity titrator, after the unboxing and making sure that everything is connected properly. Okay, so here we have the water bath, the pH probe on a stand, the titrator pumps, the pH meter, and the computer. From the water bath, from the outlet, you first want to go to your titration vessel water jacket, and then you want to go to a larger water jacket that will hold your sample, and then to the water jacket that will hold the acid. From the acid water jacket, we will go to the acid syringe, and then to the sample syringe, and then back to the water bath. We have a probe stand. It does not come with it. You will have to use your own stand for a probe, but the probe goes on the stand over the stirrer so that we can keep the stirrer in the titration vessel. We also have a waste container. And then you'll want to have your 3 buffers, the 4, 7, and 10 buffers. You also want to have some DI water and a little catch for the DI water, stir bars, and multiple titration vessels. And a few details about the tubing and the instrument, what comes with it and what doesn't. We do not provide the tubing between each water jacket. It is a 1/8 inch ID tubing that you will want to use. We have here latex tubing, but any tubing really that can transfer water will work for it. The barbs are 1/8 inch barb. You will need some female lure locks. The system does come with these tubings connected with a male lure lock on the end, and the connection between the 2 syringes is also provided and will be part of the system. We also provide the tubing for the transfer. And then we also want to make sure these water jackets are working properly. The water flows from the bottom to the top and out the top. But once you put your sample in, you'll want to pour enough water inside the cup itself to cover your sample and your acid. That way the heat transfers from the water jacket to the water to the sample or the acid. Same thing with your titration vessel. You'll want a little bit of water in there to cover your sample, so when you put it in, it's also having the heat transfer. Okay, so moving on to the pH probe and making a pH calibration measurement. To set up the pH probe, you'll want to remove the storage cap, as you've seen here. It is a compression fitting, so you don't have to completely unscrew the cap, you just have to loosen it up so it moves. On the back of the pH probe is a fill hole for the reference solution. You want to make sure your reference solution level is no more than a 1/2 inch from the top of the fill hole. On the other side of the probe, there is a white gate, and that is where the pH measurement is actually made. So we'll want that facing forward, and we'll always want to make sure that that white gate is below the liquid level of whatever we're measuring. So now we'll put this back into the probe holder. Make sure it's set. Again, we have 3 different pH buffers, the 4, 7, and 10. I have poured out a little bit from the pH buffer bottles that come with the instrument into these smaller vessels. It's easier to measure, and it also saves the pH buffer in the bottle. So we will remove a cap, and we want to put that in the titration vessel with the water to make sure that it's at the temperature of our measurement. Everything should be measured at the same temperature. We'll slide the pH buffer or the pH probe into the buffer, ensuring that the gate is below the buffer water level. And now we'll wait and pay attention to the software until everything is stabilized, and then we can take our pH measurement. Now, before your next measurement, you'll want to remove this out, and you'll want to clean off the probe with a little DI water so that you're not transferring one buffer to the next buffer and getting bad calibrations. To connect with the instrument, you want to make sure that your pump communication port and your pH communication port are on the correct ports. So you can click on these drop down arrows and your number of ports will be listed. You can click refresh, and if some of them were there or gone after that, they'll disappear or come up and show different ones. On this system, COM6 is the pump communication port, and COM5 is the pH communication port. You can check these ports by going into your device manager and unplugging and plugging in the USB ports, and the COM ports will disappear and reappear as you do that. On the laptop we send you, they should be the only two ports that pop up. After you get them lined up, you can click Initialize. When you click on that, you will get a screen that asks you where and what to name your file. So we will call this test and click OK. You will see on the bottom here the EMF and the pH from your pH probe, and you will hear and see the pumps move on the instrument. If everything happens and nothing pops up, no errors pop up, then you've connected. After the pumps move, you will see this pop up here that asks if you want to flush the acid pump. If you want to go ahead and flush it, you can press OK. If not, you can cancel. I am going to cancel. Flushing the acid pump is a way to ensure that any excess DI water from last use and last cleaning is flushed down the system before you make any measurements. After initialization, you'll see a pop-up that is asking you to flush your acid syringe. This is to make sure you get any air bubbles out of the syringe and out of the lines before you start any measurements, and to make sure that your lines are washed with acid. So the first thing you want to do, the acid syringe is a small 1 ml syringe. You'll want to put the acid outlet, which is port A, into a waste container. And then you'll want to use the port B, which is your acid inlet, and put that into your acid and try to go all the way to the bottom if you can, and then click OK. And the syringe will flush with acid. So as you see, the syringe is filling with acid, but there is an air bubble from the air that was in the tubing. And then it is putting it out into the waste container, dispensing into the waste container, but you'll end up with acid or with bubble lines in that line as well. And so we'll want to, that's why we do 2 flushes. The second flush removes all the bubbles out of the lines. So as you can see, the second flush is now pushing everything through and out into the waste container. So now we want to set up the pH probe and the acid line together to be ready for a measurement and calibration of the acid. Take your acid outlet, port A, out of your waste container. You'll see on the end of the tubing there's a blue piece of tubing as well that's stuck into it. It has a very small diameter, inside diameter hole that allows the acid to be delivered precisely into the sample without any extra acid being added to the sample or any acid being sucked into the blue tube itself. So depending on your pH probe, you want to put that tubing through a hole on your pH stand. You'll want to have the blue tubing to the length of the bottom of the pH probe. And then you'll want to take a small piece of parafilm and wrap it so that it stays in place. And you'll want to wrap it in a way that the parafilm itself will not interfere with the measurement and get into the sample. So wrap it up high. You'll want to stretch the parafilm out so that it stays nice and tight and sticks in place. And now we have the pH probe and the acid line ready for a measurement. So now to make an actual measurement, the first thing we want to do is make sure that our sample line from the larger sample pump on the left-hand side is placed into our sample. It is best to have that go all the way to the bottom of the sample for any CO2 gas exchange. we'll want to make sure the outlet of our sample syringe is in our waste container as well. Again, we have a smaller piece of tubing on the sample outlet to control how much sample we're actually putting into the titration vessel. So now we're going to do an acid calibration. I first flush the acid syringe 2 times using this button here. I've already done that, but we want to make sure that the inlet port B of the acid syringe, which is the 1 ml syringe, is in your acid, and the outlet port A is in a waste container. And then you'll want to go ahead and click flush acid syringe, and it'll flush it 2 times to make sure that there are no air bubbles in it. You can enter your calibration in the box here for concentration HCl, or you can calibrate your acid if you don't know the exact concentration. To do that, you'll want to click on the green button here on the bottom right. Make sure that your pH is recently calibrated. Enter your standard ID, so I'm using a Dixon CRM, batch 218, and serial number is on the side of the bottle. I like to put that as well, it's not needed, but this is how I label it. It says 218-0596. And then we're going to use 20 mils of that. The total alkalinity by Dixon, you can go to his webpage, or you can go to Google Dixon CRM. It's the first NCEI NOAA page, and looking that up, I see it here. So it's giving in micromoles per kilogram. And you can see here, we're looking for micromoles per liter. To convert those, you can click on these refresh buttons. Enter the micromoles per kilogram. So here on Dixon's page, it's 2197.08. The salinity is 33.11. And the temperature of measurement is 22 degrees C. We use the temperature of measurement and the salinity to determine the density. We use the density to then determine the micromoles per liter. As you can see, once I click off, it automatically calculates and gives it down here. So when you click OK, that is the value that is added into the total alkalinity box. My acid is around 0.1 is a good estimated concentration. We don't need to know exact, that's what we're doing the calibration for, and it will find it for us. So you click OK when you have all that filled out. And then you follow directions here. Make sure that you have your acid connected to the proper lines. Click OK. Also make sure that you have your sample connected to the proper lines, not just your acid. And then click OK. What we'll see now is the sample syringe will pull 2.5 mils, that is to wash this tubing, and it'll dispense it into the waste container. It draws another 2.5 mils to remove any air bubbles that could be in the syringe. And then it'll draw the sample volume that you've input. And that, again, will be dispensed into the waste container so that this washes the syringe. It only does these 3 steps on the very first measurement. If you do a repeat analysis, it does none of these steps because you're repeating with the same water. And so everything is washed the same water and there's nothing to wash. Once it all dispenses out of the syringe wash, it will again pull the 20 mils that we've input in it for the sample volume. It pulls it a little bit slower, this way it doesn't create any cavitation bubbles, and it's a nice solid pull for measurement. It will stop and wait on the software. It will ask you to move the waste container to the vessel. When you hit OK, it will start the measurement. So we want to go ahead and put our stir bar in. we want to take our outlet of the sample and put it into the titration vessel and click OK. So it's now pulled the 20 mils of sample and it's waiting for me to be ready to dispense it. I am ready, so I will click OK. It will dispense the 20 mils of sample into the titration vessel. As this fills, I keep the tubing right above the water level to reduce any splashing or any bubbles that can happen in the sample. If you have any sample that ends up on the side of the container and not in the liquid itself, it will not be titrated and you can have bad measurements. So once it's full, we'll move the titration vessel to the water jacket. We'll want to turn the stirrer on. And then we'll want to put our probe into the titration vessel, making sure that the acid line goes in with it as well. And again, remember the white gate on the probe needs to be below the water line. You want it as low as you can, but you don't want to hit the stir bar on the bottom. You don't want to be, you can possibly break the probe. So we'll keep that off the stir bar. And then you'll click OK. The titration unit will pull 1 mil of acid syringe and the titration begins. So from here, it's going to measure the pH to make sure there's enough alkalinity to do an actual titration. That's the first pH that it takes, and it doesn't have to be stable. Again, it's just looking to make sure that there's enough for an alkalinity. So you can see our initial pH here is coming up and is looking for a nice stable pH. It has 2 minutes to look for that stable pH. If it doesn't, it will just move on to the next step. Again, that is okay. We don't need a stable pH for this first reading. And so what it considers a stable pH are 4 pH readings that agree with each other. So you can see here we have 7.8, 7.8. So there's 3, 7.8, 7.8, 7.8, 7.8, 7.8, 7.8. If the fourth one agrees, it'll move on. It doesn't, so it's going to continue to read. But again, we have 2 minutes to find it. If it finds it in that 2 minutes, it'll move on. If it does not, it'll just move on at the end of 2 minutes. No, and there's 4, and so it moved on. It recorded that in this graph, or in this chart here. Again, this pH isn't indicative or part of the titration. It is just making sure that there is enough alkalinity in the sample. So it's added an initial amount of acid using the estimated acid concentration of 0.1 mils and the fact that it's more than 30, and the calibration is going to use the estimated concentrations of acid and the alkalinity entered from the salinity to calculate the initial amount. We don't want to overshoot 3.8, so we add a lower amount. And then we slowly add acid until it reaches just below 3.8. And then we'll use this first titration point, 30 seconds. That gives 30 seconds for the gas of CO2 to evolve out of the sample and give us a better pH reading. So here it is, we're below 3.8 now. So this 30-second timer is started. Again, this allows all the CO2 to come out of the sample as the stir bar is turning. So now that our countdown is stopped, it's going to look for the first pH point. We want a stable pH. Again, we want 4 pH that agree with each other. So you can see a little bit more CO2 is still coming out, and that's why the pH rose just a little bit. But now we have 4 stable pH readings, so we'll use that. We'll add a little bit more acid. This titration is from 3.8 to 3.0, so we're looking for all those points in between that we can get. You can see on the right hand side here, this graph charts out your pH versus time plot and just shows you how it steps down. In between each pH step, we do add a little bit more acid. As you add more acid, the change reduces as you get closer and closer to the pH of the acid itself. So you have to add exponentially more acid from each step to get a similar pH change. This is looking to be our second to last step as we're at 3.0. So yep, we're below 3.0, so this will be our last pH reading, last point in this titration. You'll want to have 5, 6, at least 5 titration points. 6 is better, 7 is even better. So you can see that ended the titration. The gram factor versus the amount of acid is regressed in this graph here. The red point here is the amount of acid used to neutralize all the alkalinity with no extra acid. We use that against our total alkalinity, and we get this concentration of acid here. As you can see, we estimated about 0.1. It's a little more. We'll say yes. And what you're looking for here is 3 calibrations that are within 0.1% of each other. So this will ask you to continue on with a standard sample analysis until you have at least 3, and then you can start choosing which ones you want to use from there. So I will click yes, and then it will sample the 20 mils again. It won't do any rinsing because it's already been rinsed, and then the titration starts. So after 3 titrations of the calibration for the acid, you can see now the 3 concentrations are listed, and you can pick which ones you want to use, right, just by clicking on them. I would suggest using 3 to get a good average. You want to be below 0.1%. You can see my RSD is at 0.03%, so that's good. And at that point, we'll accept it by clicking accept. If you want to continue, you don't have 0.1% precision, you can click continue and you'll move on with the calibration. But here we look good. Again, we're at 0.03%. We want to be below 0.1%. So I'll hit accept. Take this average right here is now the average here, and we can move on for a new analysis. So a couple little tips to talk about before you start your measurements. Your sample collection jar, you want to make sure is a borosilicate jar and not a soda lime jar, as the soda lime can leach into the alkalinity and change your alkalinity measurements, and you'll have bad data at that point. So borosilicate jar, a glass edge topper with grease to seal it is a good way to collect. You can also follow this in Dixon's SOPs of seawater sample collection. This is a 500 milliliter sampling jar. It fits well in here. The 250 milliliters fit well as well. So another thing to think about is about the minimum with this setup, about the minimum sample size is 15 to 20 mils. And that's being able to make sure that the gate on the probe actually falls below the water line and makes a good measurement. We do have a tech tip online of how to make smaller measurements, especially for pour water, where you're looking at 1 to 2 mils of water. It will require a different probe and a different titration vessel. You can go online and find that tech tip online. So now we've seen how to set up a measurement and take a measurement with the software and with the movements between the samples and the different pumps and the pH probe. One thing to keep in mind is that you really don't want to wait and waste time waiting for your sample to come to temperature in this water bath here. It'll be good to have a water bath that you can actually set your next samples in, and they'll be at temperature so you can move them from the water bath to your water, from the water bath to your water jacket here. They're already at temp, and you can just move to your next sample. Thank you again for watching our video today. You can contact us at ENV Support, or go to our website, or go to your distributor for any other questions. Thank you.